online afterward, so you can still watch it online. Okay, but I want to let you know that the Q&A question, the session is not going to be recorded. Okay. So that's just some basic rule about the webinar. Okay, so now let's get started. Hello everyone. So welcome to our third IIOA webinar this year. So I'm Kui Shuangfeng, a member of the IIOA Council, and also now the lead of the IIOA webinar series. So now we start recording. Okay. So we are so glad to have Professor Manfred Lenzen as our today's speaker. So Manfred, I think most of us know, it's well-known professor, particularly in the IO community. So he's a professor of sustainability research with the integrated sustainability analysis team in the School of Physics at the University of Sydney. So he has a PhD in physics and experience in renewable energy technologies, life cycle assessment, and carbon footprinting. And his current work interests focus on the link between environmental resource impacts and the international trade. So he is currently leading the development of cloud-based collaborative research platforms for building large-scale global economic environmental models that enable environmental impact analysis across the global supply chain network. So today, Manfred's talk is affluence, equity, and degrowth in the context of climate change. So the presentation will be about 30 minutes, and will be followed with Q&A for about 10 to 15 minutes. Okay, Manfred, thank you again for giving us this talk and contribute to our webinar series. And the floor is yours now. Thank you.
Yes, thank you for the kind introduction, and welcome everyone. As you can see from the title slide here, this talk will be about there are rich people and low-income people. But let me first start with what is the problem? So you've probably seen this hockey stick curve. We're observing now temperatures that we haven't observed in about 2,000 years. And warmest multi-century period in more than 100,000 years. Now this is a temperature, and CO2 concentrations are even higher than at any time over the last 2 million years. And we also know about the sea level rise. It's actually accelerating, as you can see from the data in the slide. So basically what this hockey stick is telling us that whilst there have been periods in Earth history that are longer than 2 million years ago where we've had such conditions, never ever have they changed so rapidly. At the moment, just to give you an update of where we're now, right now, when we experience a triple dip La Nina event. And now this has been sort of masking the temperature increase. So because of the La Nina, we should see it a little bit cooler than we would expect from temperature anomaly changes. But Jim Hansen, ex-NASA, he's a well-known climate modeler. He's saying that when this La Nina will finish at the beginning of next year, so 2020-30 will be about in the dead heat with 2017. And the expectation is that 2024 will again break all records. And we may well, in 2024, have 1.5 degree a year, but we don't know, but it's possible. Now 1.5 is baked in, we know this. There is no way to to avoid it. It doesn't matter how much we reduce. And under the sort of middle of the road current policy scenarios, which is SSP2 in this graph, will be crossing 2 degrees around 2050. Now, what 2 degrees means is there's a recent publication from Science that there will be we'll be increasingly crossing tipping points. We already likely crossed some, like the Western Arctic ice sheet, coral reef and boreal permafrost, but we'll be crossing more by 2050. Now, you may be forgiven that, you know, if you look at this globe, at this map here with these tipping points, that you think, oh, well, these things that happen in low-lying islands, and they happen at countries where people are poor. But, you know, actually, this is not the case. Look at this video.
You know, the politicians, particularly our Prime Minister, love to tell us how resilient our communities are, how he knows we build back. And it's like, yeah, we're being resilient because we have to. How about helping us? This isn't about people who didn't take the right precautions. To leap from known historical records and then just top it by 2.5 metres is incredible. Now that led to a terrible emergency.
In dire straits here, can't get onto the roof. Thinking it's starting to swim to the neighbours. Not sure what to do from this point.
Yes, not sure what to do.
You know, the politicians...
Not sure what to do from this point onwards. And I think that's an answer that a lot of us will probably give, confronted with that question, what to do from here onwards. Well, the IPCC report on global warming of 1.5 degrees has a few things of where we must head. And to stay below 1.5 degrees, that's what the report said a few years ago, we must have by 2030. Now keep that number in mind for the rest of the talk. These are different trajectories. Yeah, the current policies, they will see us having about just crossing 3 degrees by 2100. If all countries make good on their pledges in the Paris Agreement, we'll be seeing about 2.63, and that's if they make good on their pledges. 2 degrees and 1.5 degree pathways, as you see the red and blue band, they're characterized by something that the others don't, and that's a kink. You know, from, well, this curve relates to 2012. Now we're in 2020, and we still have increasing. So, and a kink is normally what a large system does. A large system just peaks and then slowly declines. But anyway, so you can see there's a big difference with what we're doing now and where we should be heading. Roughly, you can say that staying under a particular temperature threshold is about carbon budgets. So for the 1.5 degree threshold, we have about 550 gigatons CO2 left. You know, it's largely independent of the trajectory along which we emit those 550 gigatons. Largely, you know, it's a good proxy for that. You know, also keep that number in mind, right? So this is just you know, climate change in 10 slides. Where are we now? Now, what determines countries' emissions? You've probably seen diagrams such like this. Now, the global west is a top emitter. We've got, you know, Canada, the US, and Australia, but also we've got Middle East, you know, OPEC countries, large emitters. But have a look at, but this is not necessarily because these countries have a high energy intensity. In fact, they don't. You know, Australia and the United States are about middle of the road, as you can see from this arrow coming in from the right. The real reason is that these countries are rich. You know, so basically, this beautiful correlation shows you if you're rich, then you emit a lot. What are the drivers of emissions? So this curve shows the carbon intensity of economies. And you see basically what this graph tells you, that over the last 3 decades, technology has gotten better, more carbon efficient. The rate is about 2% per year. So we make better vehicles, better gadgets, better everything. And but affluence is growing at 3% per year. So you can see that's 1% higher than all our technological improvements. So every one of us wants more per capita. Now, population growth adds a little bit to that, maybe 0.5% per year. So you see you have 2 accelerators, which is population growth and mainly affluence, and 1 decelerator, which is technology. And combined, you can do this with the structural decomposition analysis. I'm sure a lot of you have seen those. The top graph is from the OECD, the bottom graph from one of our papers. And basically what this tells you that affluence, meaning consumption per capita, which is the middle world map, is and population to a smaller extent, they're completely outpacing technological improvements. So we are, with our technology, chasing a receding target. Now, where are those consumption growths? A lot of them are in countries that are developing, like in India, Africa, parts of Central and South America, and also China. Like, for example, in India, there's many villages that yet have to be electrified, and where people, want to embark on trajectories that are not unlike the ones that we've in affluent countries have embarked on. And that, of course, makes it complicated for international negotiations, because who are we to tell that people in those regions should not grow? But also in richer countries, we have tourism. Tourism has an elasticity of larger than 1. That means if you're richer, then you consume even more tourism. There's no saturation. And it's what people like to do. They have only one life, and they'd like to have some experiential consumption, and that is tourism, and that means flying. So basically these results, of which some of you have seen, they tell us we need to address lifestyles. Lifestyles are an important factor in this story of climate change. And some of you might ask, well, but aren't we decarbonizing? We're hearing all the time that we're decarbonizing. Well, look at these curves here, which is the CO2 emissions per capita. United States and in the UK, they seem to be declining. But some of this decline is due to the outsourcing of emissions here, for example, from Germany into other regions. So if we're shifting dirty production overseas, a lot of it to China. And a recent study has shown this, whilst the minister in the UK was peddling the truth that emissions of the UK were declining, in reality they were increasing once you've incorporated imports into the picture. And it was a little bit embarrassing, which we of course liked, because it forced the minister to go on BBC radio, and this is the news clip from that. So that's what drives emission. Again, it's consumption. So you've seen in this one slide, that some of it happens in low-income countries. So we need to address equity. Equity is a game changer in the climate change nexus. It's not exaggerated to state it like that. So how can you approach this equity issue? Well, from a moral point of view, you'd say every person has the same right to use this remaining budget of 550 tons, right? And at the same time, as we saw from the IPCC report, you must halve emissions by 2030. Now, let's halve emissions. That's this green circle. So now we're at about 55 gigatons per year. So halving that would be 27 gigatons in 2030. Now divide 27 by 7.5 billion people, and you get about 3.6 tons of CO2 equivalent per capita. So that budget, 3.6 tons, would mean we'd have a chance to stay underneath 1.5, and everybody would have an equitable share. Now, as you can see from this graph, the y-axis is per capita emissions. Most of the affluent countries emit far more than 3.6 tons. And to the right, we have the low-income countries. They're the ones, and it's the majority of the world's population that emit less than 3.6 tons per capita. And now, I've put in a bar, like I said, that starts from Germany. From its current emissions, if Germany wanted to reduce emissions to that equitable level, 3.6 tons, that would be a reduction by 70%. To be equitable and 1.5 degree compliant. The question is, well, could we reduce our emissions by that much? Well, and that's sort of a role play that we often do in our classes at senior uni, when people say, well, if the people that then take the role, the perspective of low-income countries say, well, we already live on less than 3.6 tons, so what is your problem in the rich affluent world? And and then some say, well, but we can throw technology at it and mitigate our emissions. So let's throw technology at this yellow arrow there. Well, is current mitigation working? Let's have a look what options we're using. So basically, there are three mainstream pillars of climate change mitigation. That's efficiency, which means gadgets, that's renewables, wind, solar, and so on, and that's negative emissions technologies or carbon capture and storage, right? So efficiency in this diagram you see on the x-axis, that's basically decoupling. We decouple economic growth from emissions growth by making our technology more efficient. And this axis shows you the difference between monetary growth and emissions growth. And the further to the right, the better. Renewables, that's the y-axis to the top. And so that's basically we need to add those exajoules per year of wind and solar as much as we can. And then the circled size in this graph, that is the extent of negative emissions technologies, for example, carbon capture and storage. And these dots there, they are IPCC scenarios. The IPCC has more than 200 scenarios, and some of those are 1.5 degree compliant. And you can see from this diagram, first, the location of the points, you need to either decouple a lot, or you need to throw a lot of renewable technology into the economy to stay below 1.5. If you don't do either of them, which means you're close to the origin, to the left, the bottom left, then that means you have to put a lot of negative emissions technologies and deploy those. So how are we doing with that? Well, carbon capture and storage, that's basically you capture the CO2 from smokestacks and you pump it into a subterranean reservoir and hope that it stays there. So here are some statements from a report from the Global CCS Institute. Now, they're not critical of CCS. They're actually advocates of CCS. And they pick up some of the IPCC's projections. At the moment, we're doing 3.5 megatons, million tons. And 3 of those 4.5 megatons are to recover oil and gas reserves, to squeeze the last bit of oil and gas out of these subterranean reservoirs. What the IPCC says, you have 5 gigatons. That is a factor of 2,000 more. And the Global CCS Institute says if we want to get to 3 gigatons, then we need about the size of India to plant those trees that we need to fuel those power plants with, from which we then capture the carbon, because then only then have we taken CO2 out of the atmosphere. And in order to grow all those trees on the land the size of India, we need about 2 times the annual world use of irrigation water. So that gives you an idea about this silver bullet of carbon capture and storage, right? So you can see that those circles, they're very unlikely to eventuate. Yeah, and you could ask, well, how about renewables and decoupling? How are we doing on that? And now I'm going to add to that diagram the historical, bits, and that's the bottom left. So that's what we've been doing historically. As you can see, on every measure, we'd have to ramp up technology so much that, if you ask me, it looks like science fiction. So another very instructive way of depicting this is that one. I look at this diagram with my students and I ask them, well, wind back time to the year 2000. What would have been necessary in that year to be on a trajectory that keeps us below 1.5? Well, it turns out it's about a 2.5 degree decrease year on year of emissions. Now, you've seen from the structural decomposition results I've showed you earlier on that technology can do that. Technology is able to reduce emissions by 2.5. We just would have to freeze affluence. If you ask a lot of people, what was life like in the year 2000? They say, it was not too bad. Maybe a better distribution of wealth, but, happiness-wise, wasn't that much different. But because we haven't frozen affluence, then we have kept on emitting more and more and more and grown per capita. So now the rates are, well, this is 2009, now the rates are about 7 or 8% per year. So this cliff is getting really, really steep. And there's no way, we have no experience whatsoever to mitigate 7 or 8% per year. We have no experience whatsoever to do this with technology. If we just throw technology at this problem, we will not get there. We will not even stay below 2 degrees. It means, again, lifestyle changes. We need to look now at lifestyle changes. We've waited too long to leave this problem up to technology. Okay, you might ask, lifestyle changes. So what do we do? What do we do? Well, that's where we get to degrowth. Now, degrowth, a lot of people are not fans of degrowth, like, for example, US climate envoy John Kerry. John Kerry said, well, 50% of the carbon reductions needed to get to net zero will come from technologies that have not yet been invented. Whoa, he seems very confident. But Greta Thunberg, she responded to this announcement as follows: great news. I spoke to Harry Potter and he said he will team up with Gandalf, Sherlock Holmes and the Avengers, and we get started right away. So you can see that many young people, they don't buy into this. They say, well, this is this promise. Why should we believe in that promise and when our future is at stake? So again, technology, I say there has to happen more than that. Also, the global South is saying, that these strategy of eternal growth, they're unfair to the South, because you cannot ask the South to mitigate when the problem is really a problem of the global North. Okay, so people in the global North, how do they react to that situation? And here I cite a social scientist, Kari Marie Norga, she's Norwegian, and basically you see it from the title. We don't really want to know. So basically, denial. We react to these news with denial. We don't really want to, know all these things in our daily lives. Why? Because they're uncomfortable. I've looked at these graphs. Remember that 70% from the slide earlier on, when Germany needs to reduce by 70%. What reductions have you been used to? Well, you see that kink around 2009, to the right, top right, that was the GFC. That was about 5% dip in emissions, and then it rebounds. COVID is the same. 5% dip, and now it's been rebounding. It's a bit above pre-COVID times now. But let's go further back. Let's go to the 1930s. That there's also a kink in the red curve for Australia, and in the yellow curve, United States, and that was the Great Recession in the 30s, and energy consumption then dipped by about 30%. And if you go to Japan and Germany in 1946, these are the green and blue curves, energy consumption halved. In Japan and Germany at the end of the Second World War, they both halved. So 70%, can't really imagine what that means. 70%, and that is all because of equity, because those low-income countries, they want to grow. They don't want to mitigate by themselves, and they say, it's your problem, so you need to do more than everybody else. And that means we have to, in affluent countries, mitigate over and above. Now you're confronted with these figures, 70%, and then those World War II scenarios are just shown, and you go, well, what's my reaction to this? Well, delusion. Shopping is cheaper than a psychiatrist. We've got a good life so far. Those of us who are older will probably not see 2 degrees. I'll probably be dead around 2050 plus minus 5 years. I don't know. But, even on current policies, I won't see 2 degrees. So we can easily succumb to our addiction to affluence and retreat to our private lives. And that is actually what we see around us. People retreat to the private lives. It's just too much, And Norga calls this social denial. It's the reality of climate change. And now the interesting thing about social denial is that it's not an individual reaction like a smoker or an alcoholic, but it's a societal reaction, and it happens automatically. That's her research. It's very interesting. She works with communities in the north of Norway, and she, observes people witnessing buildings disappearing into the permafrost, or ships going along the coast where no ships have ever sailed in winter for thousands of years, and people don't talk about it. She noticed people don't talk about it because they know deep down that if they start talking about it, it's going to get uncomfortable, and they don't know what reaction they'll be getting, and so that they avoid it. They just deny and get on with the normal parts of their life. We can also see this if you want to have scientific studies about this, there's ample evidence of this. People who know about climate change, they're usually concerned, but there's no action. The carbon footprint of people who know and concerned about climate change are often higher than the carbon footprint of those who do not know about climate change. Or the carbon footprint of those who vote left and green are often higher than those who vote liberal and right. That's just what it is. There's no correlation. And of course, our advertising landscape surrounding us also doesn't help with this way. There's 10 simple ways to save the world, and easy tips to save the planet. Of course, that totally supports the denial, and to embark on degrowth in such a world. You might say, I've told you with that graph that you'd see, technologies I mentioned. I think it's science fiction, those technological rates. But then, degrowth. I'm not saying that degrowth is likely, as you can see here. But the message from the people who are proponents of degrowth say, at least we need to start talking about it, because if we don't, we are surely stuffed. There's no other silver bullet that can get us out of this. So that's the question I ask my students. So what do we do? Are we stuck between a rock and a hard place? And also some educators to say, well, you can't have people face this whole challenge because they get paralyzed by guilt, anger, and depression. Well, okay, if you accept this, what's the alternative? make the information palatable, give them sort of bits and pieces to absorb, but then they're not acting. They won't, because they don't know what the true story is, and then we will certainly miss the 2-degree target. So what of those two do we do? So, and here's some quotes from a book by Leslie Head. It's advice for Anthropocenians, so people who are born after 2000 and live in the Anthropocene. And Head says, well, we might have to accept that the things we can do easily may have little or negligible impact. All those things that mean that we'll still have a comfortable life. They'll have no impact or very little impact. 2, accept that we are reluctant to embark on unnecessary radical changes to our comfortable and convenient lives, even at the cost of the present poor and future generations. So what she's saying here that, people recycling aluminium and switching off lights, they get a warm glow from this, but really, they're not making a big difference. Unless you've completely overturned your life, you're not making a big difference. And Head says just accept that. And 3, that's her advice, get prepared for grief, because is that Anthropocenians have to learn how to grieve because they will be faced with loss. There is no way around this. Thank you. And now into questions.
Great. Thank you very much, Manfred. Yeah, this is a really important topic in particular. It's certainly our current century's challenge. I would say the biggest challenge. And also degrowth, I guess, it's certainly, something that we need to discuss. So now we stop recording. So we are entering to the